the Ayub Mahi. My major is biochemistry and biotechnology. And today I will discuss the topic chemical bond. This is a very important topic. Now let's just get into it. Firstly, we have to know why do atoms form bonds and how. Firstly, think about an analogy. Let's assume you want to live healthy, right? For that, you have to eat healthy foods, consume healthy foods, right? And healthy food means healthy life, right? And healthy life is equal to happy life. Then the atoms similarly wants to be happy, wants to stay happy. And how they become happy? When they achieve a certain electron configuration. That electron configuration is called stable electron configuration. What is that? Stable electron configuration. Stable electron configuration. When they achieve that, they become happy. And how to do that? There are different kind of ways. We'll see into the class. One thing you have to remember, stable electron configuration means they are less reactive. And when they achieve stable electron configuration, the last shell of that particular atom is more stable than its previous state. Okay, let's deep dive into it. Chemical bonds are actually three types. One is that ionic bonds, second covalent, and third one is the metallic. Today we will see mainly ionic bonds. So ionic bonds formed by ions, covalent bond by sharing electrons, and metallic bonds by creating a flow of electrons. They are differently functionized. When you talk about ionic bonds, they will form firstly ions. And ions are mainly two kinds. One is cation, another one is anion. Cation is positively charged, anion is negatively charged. How do you know that this particular atom will form cation and this particular will form anion? You have to know the periodic table, and from the periodic table you will see the metals will form cation, which are positively charged, and the non-metals will form anion. Now, let's just get to know more about cation. Cation is the one who loses electron. Suppose an atom, sodium. Sodium, if we say the electron configuration 1s2, 2s2, 2p6, 3s1. And sodium loses one electron, this one electron, then it becomes sodium plus, and sodium plus is sodium ion. We'll see 1s2, 2s2, 2p6, 3s0. If you write that like that, it will be okay. And if you want, you can write like this. There will be no problem. Okay, this is the sodium ion, and this is called sodium ion. Sodium ion is positively charged, so sodium ion is a cation. If you see in the periodic table, if you see the electron configuration of an atom and the last number is 1, 2, 3, or 4, they will lose one. They can lose one electron, 2 electron, 3 or 4 electrons. Like if you think about magnesium atomic number is 12, 1s2, 2s2, 2p6, 3s2. This is the electron configuration of magnesium. Magnesium will lose 2 electrons. Then you will see magnesium 2 plus. Here is 12. Atomic number won't be changed. Electrons stay on the outer shells, and atomic number is the proton number, and protons stay inside the nucleus. That's why the 12 will remain unchanged, but the electrons will change. 2s2, 2p6, here 3s0, we don't have to write that. Here you will see magnesium 2 plus, and that's also a cation. And if you see in an electron configuration, in a large shell, the electron number is 5, 6, you can say 4, 5, 6, or 7, they will gain electron. And how they gain electron? We'll see that. Firstly, let's see one. Chlorine has 17 protons, and likewise an atom has the equal number of proton and electron, right? Then electron configuration 1s2, 2s2, 2p6, 3s2, 3p5. Here we can see the first shell has 2 electrons, the second shell has 2 plus 6 is equal to 8 electrons, and the third shell has 2 plus 5 is equal to 7 electrons. And here we saw earlier, if we see in the last shell of an atom there is 4, 5, 6, or 7, then they will mostly form an anion. Here chlorine will form an anion. And how they form anion? By achieving one electron, by gaining one more electron. Then if they gain one more electron, they will be negatively charged because there will be increase of one electron in them. There were previously 17 electrons. If chlorine achieves one more electron, there will be a total of 18 electrons. Okay, let's see the configuration. 2s2, 2p6, 3s2, 3p6. Here you see 2 plus 8 plus 8. That is the more stable configuration than this one. This is the more stable one. And a bond is formed with the stable configuration. That means if you want to form a bond between sodium and chlorine, they will form sodium will form sodium plus cation, and chlorine will become chloride cation, right? So sorry, chloride anion. Then they will form an ionic bond. And of course, you have to remember, always there will be a metal and a non-metal when you form ionic bond. There will be a metal plus a non-metal. Here you can see sodium is a metal and chlorine is a non-metal. Okay, let's see the electron configuration here. Sodium plus chlorine minus. You will say this sodium ion, this is chloride ion. Here they form sodium chloride. This is the dot cross diagram to visualize what is actually happening. In the first shell, there are 2 electrons, sodium, then 8, then 1 electron. 1 electron will transfer to the chlorine. Chlorine will gain 1 electron and sodium will lose 1 electron. If sodium loses 1 electron, then sodium becomes sodium plus ion, and chlorine gains 1 electron here. Here you can see 1 electron. That means it is chloride ion. You should say this is chloride ion. This is sodium ion. And this is how they form ionic bond. This is very, very easy. If you attentively to the class, you will understand that. And now, how to recognize ionic bonds? Isn't that a question actually? Because there are 118 atoms in the periodic table. How will you know actually that it will form an ionic bond or a covalent bond or a metallic bond? So if you see the periodic table, there is group 1 and group 2. They are mainly metallic groups, and group 13 to group 17 are non-metallic groups. Okay, we'll see at the end of the class how in the periodic table and the lattice structure as well. Now let's get into the properties. Ionic bond has some certain properties. Melting point, boiling point. You know about water, H2O, and water has a covalent bond. Water has a melting point 0 degrees Celsius and a boiling point 100 degrees Celsius. You see the difference isn't that much when you will see the ionic bond is actually very higher in temperature when you will see the melting point or boiling point. Let's talk about sodium chloride. Sodium chloride. Think about a very tightly bonded friendship. And if they face difficulties, will that friendship break easily or not? Certainly, the friendship will remain, right? Likewise, sodium chloride has a strong bond within them, and there is a force. There is a force between them. There is a force between them. It's called a force between them. It's called electrostatic force. Electrostatic force. And this force is very strong. You have to hit a lot to break the force between them. And you can see when the temperature goes in 801 degrees Celsius, the sodium chloride starts melting. And approximately more than 1400 plus degrees Celsius, 1400 plus degrees Celsius. Are you seeing the difference? Electromagnetic force, electrostatic force is very strong. That's why the melting point and boiling point is very higher than H2O. The sodium chloride has a very high melting point and boiling point. Now let's see solubility. Suppose this is a glass and you put some sodium chloride in it, and there is already water. Water means H2O. And how sodium chloride break into water? Isn't that a question? Because if it didn't break, then you would see the exact same lattice or same structure you have saw before when you were putting inside the glass. Let's discuss this. Sodium has sodium ion and chloride ion. And water, though water is a covalent bond, water is a polar compound as well. A polar compound is something which has a slightly positive part, and a slightly negative part. Slightly negative part. Here you can see, slightly positive part and slightly negative part. Now let's see how actually sodium dissolves into water. When sodium chloride goes into the water, it divides into Na plus and Cl minus. When you see the water has a slightly positive part and a slightly negative part as well. Oxygen here is the negatively charged one, and hydrogen here is the positively charged one. We used here delta plus, and 2 delta minus because hydrogen is slightly positively charged. If we see that is partially charged, we will use delta sign. And if it's completely positive charged, then we don't use delta sign. So when water comes here, the negative part will stay with the will face toward the sodium plus, and the positive part will face toward the chloride ion. Okay, let's see the negative part, and here is the positive part. And here the negative part will the positive part will face towards the chloride ion, and negative part will stay on the opposite side. And that's how the water actually dissolves sodium chloride. That's why we can say ionic bonds are soluble. They have soluble properties. And lastly, we'll see conductivity, how they conduct electricity, how they produce electricity. Ionic bond has a plus part and a minus part. If firstly, let's know how electricity occurs. Electricity occurs by flow of electrons, by the flow of electrons. And here in ionic bond, electrons are flowing. You saw in the diagram before. Here you saw in the diagram, electron is transferring from sodium to chlorine. So you can clearly see how actually electron is flowing. When the electron flows, it creates electricity. That's how ionic bond creates conductivity. We saw sodium plus chlorine forming sodium chloride, and sodium becomes sodium plus ion, and chlorine becomes chloride ion. And this is sodium chloride. There is a force between sodium plus and chloride ion that's called electrostatic force. And if I take magnesium instead of sodium, you can see magnesium has an atomic number 17. Sorry, magnesium has an atomic number of 12. 2 plus 8 plus 2 is the electron configuration. And to achieve the stable electron configuration, it has to lose 2 electron. And if I take chlorine as a non-metal, chlorine's atomic number is 17. 2 plus 8 plus 7 is the electron configuration. Here we are seeing in the last shell there is 7 electron. It has to achieve one more electron to be stable. But magnesium is losing 2 electrons. Here is 1 chlorine. That's why I need another chlorine. That means 2 chlorine will take 2 electrons, and they will become 2Cl minus, 2 chloride ions. Thus the formation will be magnesium 2 plus 2 chloride ion 2. Sorry, here will be magnesium chloride. Okay, if you think about magnesium plus oxygen, it will be magnesium oxide. And how is this? How did I get this first? It's pretty easy. Magnesium electron configuration 2 plus 8 plus 2. And oxygen has 8. Oxygen's atomic number is 8. Thus its electron number is 8. And its electron configuration will be 2 plus 6. That means oxygen needs 2 more electrons. That means from magnesium, 2 electrons will be transferred to oxygen. That means magnesium will lose 2 electrons. That will form magnesium 2 plus cation, and here will be oxide ion O2 minus. And here will be the compound magnesium oxide. There is a home test for you guys. Calcium plus oxygen is equal to calcium oxide, and calcium plus chlorine will be calcium chloride. So try this out. Next, we will answer a basic question, very basic question. The question is, why does an atom show neutral character in its base form? Think about it for a sec. Okay, we all know about hydrogen. Hydrogen's atomic number is 1, right? Hydrogen's atomic number is 1. If we think this is a hydrogen, H for hydrogen, and this is the nucleus of hydrogen, inside this nucleus, hydrogen has one proton, and 0 neutron. And if you think about in the outer shell, there is one electron. And we know electron has negative charge, proton has positive charge, and neutron doesn't have any charge. So in an atom, the number of electrons the number of electrons is equal to number of protons, obviously in its base form. This will be considered in base form, not in cation or not in anion. That's why positive charge and negative charge neutralize each other, and thus an atom is always neutral. But if you think about a cation or anion, this is not neutral. Why? Because in sodium there are total of 11 proton, and if you think about sodium plus, here is 11 proton, but sodium leaves 1 electron, then there will be 10 electrons. If we count the charges, 10 electron has 10 negative charges, 11 proton has 11 positive charges. If we add, then it will be plus 1. That's sodium cation. Try check it for chloride ion. Next, we can see another topic, another question. In which form ionic compound conduct electricity? Is it solid, is it fluid, or is it gaseous state? The answer is close to fluid, but not actually fluid. It's not totally fluid, but it's the melting state. You saw earlier for sodium, we saw the melting point 801 degrees Celsius, and if a sodium melts or starts melting, it will conduct electricity, not in solid state. That's a question, important question. Now, here you can see, here you can see there is group 1, group 2. Group 1, hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. Group 2 has beryllium, magnesium, calcium, strontium, barium, radium. And from group 13 to group 18 has uh, many atoms, right? And they all can act as non-metals, mostly non-metals, but all of them are not non-metals. In group 1, you can say here it will be the outer shell will have 1 electron, group 2 will have 2 electrons. In group 13, there will 3, 4, here it will be 5, here it will be 6, and in group 17 there will be 7. Previously I said that if the outer shell has 1 electron, 2, 3, or 4, it can form cation, that you can add plus 2 and plus 1, plus 1, plus 2, plus 3, plus 4. And I said if the outer shell has 4, 5, 6, or 7 electrons, it can form anion. That means -4, -5, -6, -7. You can ask, in number 4 we did +4 and -4. Why? Because in this form the atom is not actually metal or non-metal, they actually act as metalloid. So that's not the topic here. That's why we didn't go into that. That's all from periodic table. So thank you everyone. Thank you. If you like the class, then like, share, and subscribe.